All right, in this video, we're going to talk about the 8-3 individual test. And the first question, and we're going to start with the edge elastic and then move on to the paper pencil. The first question asked you to find the value of the red car, which is here, the green dinosaur, which is here, and the blue bear, which is here. So in order to find those things, you're going to have to complete it's called a Polydoku puzzle. Our textbook calls it that. Really, it's just completing the puzzle of division. And so I know that these gray boxes, x minus 5 times whatever's up here, should give me the inside parts. Okay, and then the sum of the inside parts will go on the bottom. So I know it's negative 5 times something to give me negative 15x cubed. That's going to be a positive 3x squared. And that's not one of my answers, but it helps me get one of my answers. Because when I multiply the top times x, I'll get 3x cubed, and I know you probably can't see that, but that is the dinosaur. So I'm going to put 3x cubed there. Oh, that's wrong. Let's try again. There's no x here, so negative 5 times 3x cubed will give me negative 15x cubed. Good reason to check your work. Okay, and then when you multiply 3x cubed times x, we get 3x to the 4th power. I knew that didn't look right, which is the right answer for the green dinosaur. And then I can see that these two added together, so I do have the 3x to the 4th. These two added together are negative 17x cubed. Okay, and then I know this is x, and x times something gives me negative 2x cubed. And this box would be negative 2x squared. X squared times x makes x cubed. Okay, that's right. So the red car is negative 2x squared. Okay, and then if I multiply that times the negative 5, I get positive 10x squared. And I'm going to have to put something here. Oh, but look, they're already here, so negative x times x is negative x squared. So if I add those, I get positive 9x squared. Sorry, that's weird. That's a negative 17. And then I see that there's an 11x, so these two things have to add together to make an 11x. Negative 5 times negative x is positive 5x, and I know 5x plus 6x will give me 11x. That's how I know the value of the blue bear, which you totally can't see on the photocopy. Okay, then if I finish it, which I don't have to because I have all my answers, but just to double check or just finish the process, 6 times x gives me 6x, and 6 times negative 5 gives me negative 30, and I would also put the negative 30 down there. Okay. Question number 2 was a division problem that was already done, a generic rectangle. And you had a drag and drop, and you had to write the multiplication problem. So the side times the top is equal to what's happening when you add the insides or what the yellow is. So pink times orange equals yellow. Okay, or if you put orange first, pink second, and then yellow, totally fine. Okay, when you do the division problem, you start with the total, the yellow on top, and traditionally what we're doing is we're dividing by the pink to get the orange. Okay, again, if you had the pink and the orange flip-flopped, it's still mathematically accurate and you got the points. All right, question number 3. So we're using this graph of the polynomial. Based on the graph, what is the real root? So remember, real roots are roots we can see, and what I mean by that is we can see where they cross the x-axis. So I can very clearly see it crosses the x-axis at negative 4. Okay, that was my answer for part A. And then for part B, it says, based on the graph, what is the factor? Well, if x is equal to negative 4, and I move the 4 to the other side, x plus 4 is a factor. Okay. Then it says the graph has how many real roots? 0, 1, 2, 3. Well, first of all, if I just look at this graph, up, down, up, that is a degree of 3. Okay, that also means it has 3 roots. I can only see one spot where it crosses the x-axis, so it has one real root. And if it has one real root, but it has 3 total roots, then the other 2 roots must be imaginary. Okay, 2 imaginary roots. And remember, imaginary roots always come in pairs, so it doesn't even make sense to have 1 or 3. There could be 0, there could be 2, but 1 and 3 just don't even make sense. Real roots could be any, 0, 1, 2, 3, etc. Imaginary roots have to come in pairs, so it has to be 2, 4, 6, etc. Okay, question number 4. This stumped some of you. X squared plus 49 equals 0, and we're supposed to solve for x. Remember, this is a parabola. Okay, so it's an x squared plus 49, so it's way up on 49. It looks like this. Clearly, it's never going to cross the x-axis, which means it doesn't have any real roots. Okay, but we have to find what the two imaginary roots are. Again, it's a parabola. It has 2 roots. And you certainly could have used the quadratic formula. This time of the year, most of you guys really like this, so I might suggest sticking with that. Excuse me. The a value is 1 because it's 1x squared. The c value is 49 because the 49 is by itself. And in the middle, the x's, there are no x's, so that's 0. So I could do the quadratic formula, okay? And that's just fine. But if I don't see an x squared and an x, it might be easier to just undo. So if I subtract 49 from each side, x squared equals negative 49. Okay, to undo the x, I'm going to square root both sides, and I get x equals, now remember, something squared makes negative 49. That could be a positive or a negative, 7, because the square root of 49 is 7, and the square root of a negative is imaginary. Okay, so it has 2 roots, both imaginary, plus or minus 7i. And to get the full point, you had to put plus or minus 7i. I did give you half a point if you just said 7i. Last question on the edge elastic. Okay, for this question, given the polynomial equation below, identify all of the roots and select all that apply. So when I see x cubed, I know it's a 3rd degree, or degree of 3, which means I'm expecting 3 roots. Okay, it does say identify all of the roots. Maybe there's a double root, so maybe it's just 2. The easiest way to do this, plug it into the calculator, hit graph, and I can see 1, 2, 3 spots. It looks like negative 4, 1, and maybe 5. If I look at the table, there's negative 4, 0, 1, 0, and, ooh, not 5, and 6, 0. So I said negative 4, positive 1, and positive 6. So remember, when I'm asking for a root, it is what I am seeing on the calculator. Okay, it's not flipping the sign. Okay, so the paper pencil version had 2, well, there were 5 versions of paper pencil, and it had 2 questions. And again, I'm just going to pick and choose so you can see one example from each. If you want to go through your exact quiz, definitely let me know in class so that I can help you with that. So question number 1 just wanted us to divide, and the method that we have learned in class and that I expect you to use this year is the generic rectangle. So what we're dividing by, x minus 6, goes along the left-hand side, and what we are dividing goes on the bottom. And then I want to remember that whatever is first goes right next to the x. Okay, and then I figure out it's 3x cubed times x makes 3x to the 4th. When I multiply here, I get negative 18x cubed. And remember, the negative 18x cubed and this box have to add together to make the negative 20. So it's negative 2x cubed. And I figure out, well, what goes on top? A negative 2x squared times x gives me this. Negative 2x squared times negative 6 is positive 12x squared. And that plus the next diagonal has to make a positive 17. So I'm going to add 5x squared. Up top, 5x times x gives me 5x squared. 5x times negative 6 gives me negative 30x. Okay, I'm out of color, so I'm going to keep going with yellow here. Negative 30 and something has to give me this negative 36x. That will be negative 6x. Up top is negative 6 times x to give me negative 6x. And negative 6 times negative 6 gives me 36. Now, some of you kind of forgot how to handle if this number doesn't match that number. Okay, so this is going to be really important that you know. 36 and something have to add to make the 39. Well, obviously, that is 3. And remember, this is a remainder. And some of you remembered it was called a remainder. So my answer to the division problem is the part on top, 3x cubed minus 2x squared plus 5x minus 6. But what do I do with the remainder? I add the remainder over whatever I was dividing by. Okay, remember, it's just like if I did 21, let's say, divided by 2. 2 goes into 21 10 times with one remainder, 1 over whatever I'm dividing by. So the answer is 10 and 1/2. Okay, this is the answer that would have gotten you full credit. I think that one was 5 points. Okay. Question number 2 was, given the polynomial, find all of the roots. So again, I see this is already multiplied out, so x cubed tells me it has a degree of 3. And so I know I'm not really done until I have found 3 roots. So the first thing that I want to do is I want to put it on my calculator. And I can see from my calculator, I don't get a very good picture of what the shape is, but it doesn't really matter. So if I just sketch real quick, I see it almost looks like a line. But really what I'm looking at is on the x-axis, where does it cross? And it looks like it crosses here at -2. And I can confirm on my table that that is -2. So remember, if x equals -2, that's a factor of x plus 2. So I want to take x plus 2 and I want to divide that into my original polynomial. Now, some of them were weird like this because, I call it weird, because there's an x cubed, but there aren't any x squared. So I have to put in a placeholder, kind of so I don't mess myself up. And as I say that, I almost miss that it's 22. Okay, and again, like we did last time, I put the first term inside, x squared, 2x squared. Now to make 0, I've got to do 2 minus 2. Okay, a -2x on top, multiply to get -4x. To get to 22, I need 26 minus 4 makes 22. Up top, 26, 52. Now, when we're trying to find the roots, and I'm saying that this is a root or a solution and this is a factor, remember, if it's a factor, it better not have a remainder. This is when it cannot have a remainder. Like if I said 21 divided by 3, my answer is 7 without a remainder. 3 is a factor of 21. Okay. My last example, 2, was not a factor of 21. That's why there was a remainder. So, in factored form, which we kind of forgot to ask you on the test. So if you didn't show factored form, you did not lose points. But it was real helpful if you did show factored form, and you were, those of you that did that, you kind of showed me you knew the process and you were so used to it, you were used to writing it out. And then the next question asks for zeros or roots. And remember, that's just setting each of these equal to 0. So x plus 2 equals 0, and x squared minus 2x plus 26 equals 0. Now here, that's easy. It's x equals -2. And again, we already knew that from the graph above. This one, you certainly could try to factor. Okay, there's an x squared and an x. But if it doesn't cross the x-axis, it's not going to be factorable at all. So we're going to go to the quadratic formula. The opposite of b, plus or minus the square root of b squared is 4. -2 times itself is +4. Minus 4 times 1 times 26, which is 104, all over 2 times 1, which is 2. Okay, inside the square root, 4 minus 104 is -100. Okay, don't divide just yet. Save that dividing for the last step. I know that the square root of 100 is 10, and the square root of a negative is I. Okay, all over 2. And remember, I have to leave it in a plus bi form, so I have to separate it. 2 divided by 2 is 1, plus or minus 10i divided by 2 is 5i. So here are my 3 solutions. X equals -2, x equals 1 plus 5i, and x equals 1 minus 5i. okay? It's okay to leave it as 1 plus or minus 5i. Some of you are doing some other kind of goofy things like x equals 1 and x equals plus or minus 5i. You can't do that. You can leave it grouped together or you can write it separately. Okay? Hopefully that was helpful for you.